Hello ladies and gentlemen, welcome back to Math 30-1, Chapter 6, Trig, Section 3, Radian Measure. Now, first part of the video, we introduced you to radians, a different way to measure degree, a different way to measure the angle. Now, the beauty of radian measure is it measures the arc length, A here. So, normally we measure the angle on the inside here, the theta. But sometimes that's not possible, or sometimes it's just easier to measure the arc length. I think of this as my brother and I would fight over who got the biggest piece of cheese stuffed crust pizza. Nobody carried a protractor, but we could much easier measure arc length with a ruler. So sometimes it's easier to measure the arc length rather than the angle itself. Anyway, so this becomes important in calculus. For here, it's merely just another way to inflict pain and suffering. So, let's derive a formula. Arc length, A, is part of the circumference. I want you to realize that's similar to the angle, which is part of one revolution, or one complete turn. So A over 2 pi r, the arc length, equals theta divided by 2 pi, distance for one revolution. Now we cancel stuff out. We're down to this formula here. Theta equals A over r. Now, this is on your formula sheet. A is arc length, r is the radius. Theta is the central angle in radians. This is quite a popular question on the diploma, and I promise you're going to see it regularly. I will give you something like this. I'll expect to be able to use this formula as long as you remember you're in radians. So, simple, straightforward question. Calculate the angle to the nearest tenth of a radian. Theta equals A over r. The arc length is 6.8. The radius is 6.1. Notice the units cancel out. So, theta is 1.1 radians. Now, standard trig question is calculate the arc length to the nearest tenth. Okay, so theta equals A over r. Solve this for A. We need the radius r, and we need the angle in radians. So right off the bat, we're being sneaky here. 162 degrees times pi divided by 180 is how many radians? You have to convert to radians. Now, that becomes 9 pi over 10, and in the name of everything that's holy, do not turn that into a decimal. It's an exact value. I'll be very unhappy. I shouldn't say that. I will be unhappy if you turn it into a decimal. You should be able to go on your calculator 162 divided by 180 math fraction and get the fraction of 9/10. Anyway, this is 9 pi over 10 equals my arc length, A divided by my radius, 2.6 centimeters. So then I cross multiply. And I get a decimal approximation of 7.4 centimeters. Okay? Now, that's what I need you to be able to do. How are they going to be tricky? Well, I'm glad you asked. Let me show you the poopy questions. A ceiling fan rotates at 4 revolutions per second. If the radius of the blade is 45 centimeters, how long an arc does the blade make in 0.6 seconds? So this is flying this way. It's going to make an arc length A. Now, there's a bunch of ways to do this. The way I'm going to do it, 4 revolutions per second, so that's 4 revolutions per second times 0.6 seconds, so that's 2.4 revolutions, or 2.4 circles. Okay? So, 2.4 circles times 2 pi r, or 2.4 times 2 pi times the radius of 45 centimeters. Gives me 216 pi, which you might see as an answer, but they'll probably turn it into the decimal approximation. 678.6 centimeters. Okay? Now, that's one way, and that works fine. But if you hate radians like I do, you can do it this way. 2.4 circles times 360 degrees per circle is 864 degrees. 864 degrees times pi divided by 180, because you got to have it in radians. 24 pi over 5 radians. Now, theta equals A over R. Now, here we're looking for the arc length, so I can rewrite this as A equals theta times the radius. That's 24 pi over 5 radians times 45 centimeters, which comes out to be 679 centimeters. Okay. One way or the other. I don't care. Actually, I should be putting this here. Doesn't really matter which way you do it. Just showing you there's more than one way. They all work, as long as you can come up with the final answer. Now, a more typical question on the diploma will be calculating 2 or more arc lengths and comparing them, or quite often comparing them. But usually you end up calculating 2 arc lengths. There are 2 flies on the same blade of the fan. How much farther does the outer fly move in 1 second? Now, 1 second is 4 revolutions. Second times 1 second is 4 revolutions. 4 times 2 pi r. All right, so this outer fly is a radius of, so this is 4 times 2 pi times 45, which is 360 pi, 1131 centimeters. This inner fly, the radius is 15. Which is 120 pi. Let me move that over just a smidge. So I'm just going to rewrite this just a smidge neater. Apologize for that. And 377 centimeters. So what's the difference? Well, note here we're subtracting. Now you'll notice I keep writing this in terms of pi. In the good old days, we would leave it like that and write it as pi at the end. I'm concerned that on the diploma, I should say, I think I've seen this on the diploma, but the problem is I get to see the diploma for half an hour being supervised by the principal, so I don't remember all the tricks. But this I have seen before in the old diploma, where they talk about it in multiples of pi. Anyway, they do. So where was I? Now, I want to point out four revolutions times 2 pi is 8 pi radians. Which is theta. So we can do this. Theta equals A over R, or A equals theta R. 8 pi times 45 360 pi, and 8 pi times 15 is 120 pi. And you see we get the exact same numbers. This is 1131 centimeters. This is 377 centimeters. Okay? So more than one way to do it. Note, you have to calculate more than one arc length. Now, other thing they're going to ask you to do, calculate radian measure of an angle. So, here's a typical question. The point P, 12 comma minus 10, is at the end of the terminal arm of an angle in standard position. Determine the radian measure of the angle to the nearest degree. Okay, so it's going like that. So we're going like that. So we're going, what's theta? Now, here, I'm looking at this triangle, which is, what did I do there? Sorry. So that is 12, 10, and we're looking for the angle theta here. So this is a, oh, right angle, so it's a tangent. Tan of theta is y over x minus 10, which is minus 10 over 12. So theta, angle theta is 10 to the minus 1 minus 10 over 12 minus 39.8 degrees. Now, converting that into radians, that becomes minus 0.695. I'm not going to show you multiply by pi and divide by 180 degrees. 39.8, you're not going to get an exact value. Now, here, you're going, okay, what's the radian measure? So here's the problem. This is wrong. Minus 0.695. It's supposed to be first angle coterminal to that, so it's 2 pi minus 0.695 radians, 5.58 radians. Okay. Now that rounds off to nearest tenth, I'm sorry, that's be 5.6. Okay. Now if we did it with degrees, change color here. I'm going to think it along. What was that? Oh yes, be 360 degrees minus 39.8 degrees. That's 320.2 degrees. So 320.2 degrees times pi over 180 gives me 5.58. Wait, what? 558, sorry, 5.6, never mind. So, do it in degrees and convert to radians at the end, or convert it to radians, doesn't matter, you should get the same answer. Now, slightly sneakier question. The point minus 1/2, comma, minus root 3 over 2 lies on the terminal arm of an angle theta in standard position on the unit circle. The measure of theta, where theta is greater than or equal to 0 and less than 2 pi is blah. Now, what the heck is theta? Right. Now, this means in the circle, so 0 to 360 degrees, the first 4 quadrants, we're not looking for something coterminal beyond that, or before that. So, draw a picture. Minus 1/2 minus root 3 over 2. So we're down here in the third quadrant somewhere. So we're looking for that angle. Draw the picture. So at least you know basically what you're looking for. So we're looking for this triangle here. Redrawing it. Minus 1/2 minus root 3 over 2. That is a 3. That's a square root. That's a right angle. We're going, what's this angle here? Now, you're going, wait a minute. I've seen this before. Cos of theta is minus 1/2. It's my x value. Sine of theta is minus root 3 over 2. That's 60 degrees. This is one of those angles you're supposed to recognize. Okay, now here's the problem. This reference angle is 60. What's the whole angle? Whole angle here is 60 degrees plus 180. So this is 240 degrees. Okay. Now, 240 degrees, we're supposed to be in radians, because that's what the units are here, radians. So that's pi over 180. So that should be 4 pi over 3 radians. Okay. So far, so good. All right. Now, for those of you that don't like, you could always solve it, because tan of theta is opposite over adjacent, or minus square root of 3 over 2 divided by minus 1/2. So theta would be tan minus 1 of that. That simplifies to square root of 3, which is 60 degrees. Minus 3/2 divided by minus 1/2 becomes minus square root 3 over minus 1, or root 3 over 1, which is just root 3. So you could just simplify it that way if you wanted to. Whatever floats your boat. Now, finally, a little bit of review. What is on the unit circle? What is k, the coordinate here? Now, x squared plus y squared equals r squared. 0.6 squared plus k squared equals 1 squared. K squared is 1 minus 0.36, which is 0.64. So k, which is y, is plus or minus 0.8. Now, what's the value here? Well, notice we're in the fourth quadrant where y is negative, which means we're looking at negative 0.8 is our y value. Okay. Now, last question. What is cosecant of theta? Well, cosecant is, if you look in your formula sheet, the inverse of sine. So this is going to be r over y, which is my 1 over minus 0.8. And note, we don't like it like that, so we don't like a decimal in with a fraction. So grab your calculator. 1 divided by minus 0.8 is negative 1.2. Math fraction becomes minus 5/4. That's what I need you to be able to do. Okay? Now let's review. Any questions? Good. If you've got a question, shoot me an email. Otherwise, homework, please.